Good evening to one and all. Today, in this live lecture, we shall discuss some basic operational properties of a Laplace transformation. Actually, in the previous lecture, we have studied the Laplace transformation of some typical functions. The next bit of this syllabus is basic operational properties of a Laplace transformation. But before starting the basic properties of a Laplace transformation, we shall see what we have seen. Actually, this is the definition for the Laplace transformation. F of s is equals to integral from 0 to infinity e raised to minus st into f of t dt. Okay. These are the some basic or typical functions whose Laplace transformation which we have calculated. That means Laplace transformation of sin at is equals to a divided by p square plus a square. In this way, these are the some basic functions in which we have studied. Next, there is another one special function. That function is called as a unit step function, and here we shall find the Laplace transformation of this unit step function, or it is called as a Heaviside unit step function. Which type of this is a particular type of a function. So our aim is how to find the Laplace transformation of this step function, unit step functions here. Here the problem is find the Laplace transformation of f of t, which is equals to h into t minus a, where h into t minus a is known as unit step function, and which is defined by, how to define this unit step functions here, h into t minus a. Actually, see here, the Laplace, unit step function, our aim is find the Laplace transformation of unit step function, and that step function is f of t is equals to h into t minus a. Here in this case, h into t minus a is called unit step function, or we also known as a Heaviside function. Now, how to define this unit step function? Actually, unit step function is defined by h into t minus a is equals to 0 when t is less than a, and which is equals to 1 if t is greater than a. Okay. First of all, you must know which function is called as a unit step function, because this is a special function, particular type of a function. So you must know first which type of a function is called as a unit step function, or which function is known as a unit step function. So f of t is equals to h into t minus a is called as a unit step function. But its nature is h into t minus a is equals to 0 if t is less than a, and if t is greater than or equals to a, then it will be 1. First of all, you must know which function is known as a unit step function. Okay, so you have to write the definition of unit step function is this. Now our aim is next aim is how to find out the derivative of unit step function. आता इथं आपल्याला काय करायचे आहे पहा, ऍक्च्युअली आपला उद्देश काय, हाऊ टू फाइंड आउट द डेरिव्हेटिव्ह ऑफ unit step function. Okay, now see here, given that h into t minus a is equals to 0 when t is less than a, and 1 if t is greater than or equals to a. This is actually the definition of unit step function. Now next aim, how to find out the derivative of unit step functions here. Laplace, Laplace transformation. Okay, now we have to find out the Laplace transformation according to the definition of Laplace transformation. Which is the definition of Laplace transformation? L of f of t, L of f of t is equals to integral from 0 to infinity e raised to minus pt into f of t dt. This is the definition of the Laplace transformation for the function f of t. Now replace, here in this case we have to replace the value of f of t. Actually f of t is given, f of t means h into t minus a. So we have to find out the Laplace transformation of h into t minus a. So in place of f of t, we have to put h into t minus a. This is the unit step function in the definition of the Laplace transformation. So this is the replacement. This is the replacement. Now see here, actually student, you must know this is a step function, means it has a different values in some particular intervals. This is called a step function because it has a different values in some particular integral. That means from 0 to a, if a is less than, t is less than a, then its value is 0. If t is greater than or equals to a, then its value is 1. So our aim is to divide this integral 0 to infinity into the two parts. According to the definitions here. Which definitions we have to use? Integral from a to c here. This is the property of a definite integral. Integral from a to c f of x dx, which is equals to integral from a to b f of x dx plus b to c f of x dx. That means we have to use this property because the intermediate value is dependent. The value of a function is dependent on the value of a. So we have to split this integral into the two parts. That is, the first part is called a, means 0 to a, and second part is a to infinity. सेकंड पार्ट कुठला आहे ए टू इन्फिनिटीचा आहे, लक्षात घ्या. मग हे जे पार्ट आहेत ते डिस्ट्रीब्यूट करू. 1 मिनिट. Okay, according to the property we have distributed this 0 to a to infinity. Keep this function as it is, there is no problem. But we have divided this function 0 to a, divide this integral into two parts, from 0 to a and second integral from a to infinity. So now put this value as a 0 because we know that the value of a function, according to the definition of step function, value of this function h into t minus a is 0 from if t is less than a. That means if t is less than a means in this integral 0 to a, limits are 0 to a, means value of t is lies between 0 to a, so it goes to 0. h into t minus a goes to 0, 0 into e raised to minus pt means total term goes to 0. So first value of this first integral is 0. Keep this second integral as it is. But in the second integral, see here, if t is greater than or equals to a, then we can put the value as a 1. So replace this h into t minus a as a 1. So our integral becomes, मग आता हा इंटिग्रल कसा आला पहा, छोटा. This is the simplified form of integral. So integral from a to infinity e raised to minus pt dt. This is a simple function. So we can find the integral of this function. What is the integration of e raised to x? स्टुडंट जे प्रेझेंट आहेत त्यांनी मला प्रत्येकाने आन्सर देणं गरजेचं आहे. पहा हा, चला रे, कोण कोण आहेत प्रेझेंट? What is the integration of e raised to x? Okay, now integration of e raised to x is again e raised to x. So integration of e raised to minus pt is e raised to minus pt upon minus p. over the limit a to infinity, because the lower limit is a, upper limit is infinity for t. Now put the upper limit. Now our aim is to keep the upper limit. If we put the upper limit, that is infinity, in the e raised to minus pt, then we have solved number of problems regarding this. Then the value of this integral, h value काय आहे ते सांगा रे. If we put the upper limit in this integral, then the value becomes, काय येतं, व्हॅल्यू बिकम्स, ठीक आहे, शिल्पा पाटील, अंजली कदम, सईद, okay. If we put the upper limit, then the value of this integral becomes 0, and if we put the lower limit in the integral, then we will get, काय तो लोअर लिमिट ठेवल्यावर रे, e raised to minus pt means p into a divided by minus p. So 1 minute, I shall remove this. व्हेरी गुड, ओके. कंटिन्यू तुम्ही आन्सर देत चालायचं, चॅट बॉक्स तुमचा कंटिन्यूअस चालला पाहिजे. सो वी विल गेट हियर, if we put my 1 upon minus p as it is, then the value of this function due to the upper limit is 0, minus lower limit is e raised to minus pa. So e raised to minus pa divided by p, minus minus plus. So the Laplace transformation of unit step function is e raised to minus p divided by p into a divided by p. Okay, now we shall move towards some basic operational properties or basic properties of a Laplace transformation. That are properties that we can say theorem also, whatever may be. See here, what is the theorem? See now, 1 minute. Student, you don't write simultaneously with me. You don't write simultaneously with me. First of all, you have to understand each and every concept. Then by revising this video or by taking the screenshot, you can write after the completion of a lecture. But simultaneously you don't write, you have to first of all understand the solution steps. Okay, now see here, if capital F of p and capital G of p are the Laplace transformation of small f of t into small g of t, then for any constant c1 and c2 constants, c1 and c2, what we have to prove? Then any constant c1 and c2, see here, what will happen? Then any constant c1 and c2, 1 minute, we have to prove Laplace transformation of c1 f1 plus c2 c1 f of t plus c2 g of t is equals to c1 capital F of p plus c2 capital G of v. So this type of a property is also known as a linear transformation property. हे linear transformation चे जे property असते ना त्या पद्धतीमध्ये. So see this, we have already, we know the definition of the Laplace transformation. This is a very simple theorem, so I am going to fast to prove this theorem. L of f of t is equals to capital F of p is equals to integral from 0 to infinity e raised to minus pt into f of t dt. So L of g of t is equals to capital G of p is equals to integral from 0 to infinity e raised to minus pt into g of t dt. Now we have given the constant, consider the constant c1 and c2 such that, or by the definition of the Laplace transformation, now our aim is to find out the Laplace transformation of this linear combination L of c1 into f of t1 t plus c2 into g of t. According to the Laplace transformation, consider this as a f of t, this total function as a f of t. Then use the Laplace transformation, we shall write this as a f of t. We write this as a f of small f of t, that means this. Okay, now integral from 0 to infinity e raised to minus pt, now multiply in the bracket, ब्रॅकेट मध्ये मल्टिप्लाय करा. सो p into this e raised to minus pt into first term, e raised to minus p2 into second term, that will be this. Now you can separate the integral by the addition rule of separation of the integral. So c1 is the constant coefficient, so we can take out of this integral. That means c1 into integral from 0 to infinity e raised to minus pt f of t dt plus c2 into linear 0 to infinity e raised to minus pt into g of t dt. Okay, so c1 into f of p plus c2 into g of p, because you know that the definition for this is according to the Laplace definition. We can write c1 into f of capital F of p and c2 into capital G of p. Hence the Laplace transformation of c1 into small f of p plus c2 f of g of t, then we will get c1 Laplace transformation of f of t plus c2 Laplace transformation of g of t. So this is the linear transformation which satisfies the Laplace transformation. So and hence prove the theorem. If you have any doubt, then you can ask me. हे पहा रे, कोणाला तुम्हाला जर डाऊट असेल तर तुम्ही विचारू शकता. तुम्हाला काही डाऊट आहे का, विचारा. ओके, ठीक आहे. ओके, नो प्रॉब्लेम. नेक्स्ट, right now here theorem number second. Left first, this is the next theorem, this is the typical theorem. First translation, or it is called as a first shifting property. It is called first shifting property. This is the second theorem. These are actually basic operational properties of the Laplace transformation. Now we shall move towards the second property or second theorem. That theorem is known as a first translation or first shifting property. Now if capital F of p is the Laplace transformation of small f of t, then we have to prove that Laplace transformation of e raised to at into f of t, which is equals to capital F of p minus a. This is our theorem, and this theorem is called as a first translation or first shifting property. Because this is a basic property, because we have to solve the number of problems based on this property, number of integral problems based on this property. So you must know this property also. Now by the definition of Laplace transformation, student, what is the definition? L of f of t is equals to, here L of f of t is equals to, 1 minute, 1 minute रे, हाँ, L of f of t is equals to integral from 0 to infinity e raised to minus pt into f of t dt. So replace the value which is the given function, e raised to at into f of t. So according to this definition, we have to write e raised to at into f of t, because our aim is to find the Laplace transformation of the function e raised to at into f of t. So replace this function f of t by e raised to at into f of t on both sides. Now next, this is actually very simple process, but you must know, you must understand this. Now you can see this, you can use the indices rule in the integral 0 to infinity e raised to minus pt into e raised to at. We can take a common minus t, then we will get e raised to minus p minus a into t and keep this f of t as it is. Now see here, actually this is the integral from 0 to infinity e raised to minus p minus a into t. Consider this as a constant, is like a p, means we will get the integral of this type 0 to infinity, or we can write as like this. Yes, we shall consider this as a yes. So integral from 0 to infinity e raised to minus st into f of t. Then what is the Laplace transformation of this in the notation form? We can write capital F of s. Capital F of s. So s means you know that p minus a. So our result will be f of p minus a. Thus we can write this. 1 minute. Okay, so f of p minus a, that means Laplace transformation of e raised to at into f of t is equals to capital F of p minus a. ठीक आहे, व्हेरी गुड. अशा पद्धतीने हे लॅपलास ट्रान्सफॉर्मेशनची सिंपल प्रॉपर्टी आपण प्रूव्ह केली. ऍक्च्युअली दिस इज द व्हेरी सिंपल प्रॉपर्टी, बट यू मस्ट अंडरस्टँड द solution process or the property. Next we shall move towards the theorem number 3, second shifting property. Second shifting property, which is as like a step function, though now see here, you must understand this. If capital F of p is the Laplace transformation of small f of t, and g of t is equals to, we consider the function small g of t is equals to, this is also step function, f of t minus a, if t is greater than 0 and t is greater than a, t is greater than a, and we will get g of t is equals to 0 if t is less than a. Then we have to prove that Laplace transformation of L of gt is equals to integral from e raised to minus ap into f of capital P if a is greater than 0. Here is the necessary condition, a is greater than 0. हे पाहिजे तर थोडं करेक्शन करून घ्या. You have to write here a. T is greater than a, then value of g of t is f of t minus a, and if t is less than a, then the value of g is 0. Then we have to find the Laplace transformation of g of t is equals to e raised to minus p into a f of p if a. Also we can write this theorem in this form also. Laplace transformation of f into t minus a into h into t minus a, which is equals to e raised to minus ap into capital F of p. Here in this case, this h into t minus a is called as a unit step function. So you can ask, the problem may be asked in this way or theorem may be asked in this way, but in this case you must know h into t minus a is called as a unit step function. But by the comparison of both types of statement, you must know g of t means we can also write h into f of t minus a into h into t minus a. h into t minus a, whatever may be. Okay, हे फंक्शन समजा g of t. हे थोडं समजून घ्या. Okay, right. Now we shall move towards the next function, second shifting function. Here in this case you must know h into t minus a is the unit step function. समजतंय ना, अगोदर पाहिलेला. Okay, now we shall prove this theorem. According to the definition, L of f of small f of t, we can denote capital F of p, Laplace transformation, and this can be also written as yeah. We can also written as integral from 0 to infinity e raised to minus pt into f of t dt. Whatever may be. Okay. Now we consider, we have given the function g of t in such a way that if t is greater than a, then f into t minus a. And if t is less than a, then that goes to 0. So, as a like first theorem, first property or the proof of a unit step function, we can solve this integral. Laplace transformation L of g of t is equals to integral from 0 to infinity e raised to minus pt into g of t dt. Now this, our aim is to split this integral 0 to infinity because g of t is one type of a step function. Its value is depend on the step, that is when t is less than a, that goes to 0. If t is greater than a, that goes to f into t minus a. In the unit step function, value is 1, but here in this case the function, the value of that function is f into t minus a if t is greater than a. So we have actually splitted here integral from 0 to a and then a to infinity, means two parts. Now you know that the value of g of t is 0 if t is less than a. So integral from 0 to a means in between 0 to a, g of t is 0. So in this case we can write the value is 0. In this case we can write g of t as it is. We can write g of t. So it will be 0. You can here see this. You can also put f into t minus a. If t is greater than a, then the value of g of t we can write t f into t minus a. So in this way we will write. Okay, 1 minute. ठीक आहे. मग अशा पद्धतीनं हा पार्ट इथे येतो g of t. So we shall move towards 1 minute. So we can write integral from a to infinity e raised to f minus p to f of t minus a. So integral from 0 to infinity e raised to p t into f of t minus a. Now we shall replace this variable. We can write t minus a as a x. Our aim is to find out the solution of this definite integral. And this solution of definite integral we have to convert into the standard Laplace transformation in f of t or f of x. So we have to replace this variable in the function t minus a as a x. So put t minus a is equals to x. Then derivative of t is dt. Derivative of minus a is 0. Derivative of x with respect to x is dx. Now when we substitute the variable in the definite integral, then the value of limits may changes. It may be changes. So according to our substitution, we have to calculate the lower limit of this integral, upper limit of this integral, because lower limit is depend on this lower limit is given for t. Upper limit is for given t, means t is equals to a to t is equals to infinity. But we are going to change the variable. That means actually we have to find out lower limits and upper limit corresponding to the given limits. So lower limit is t is equals to a. So when t is equals to a, if we put t is equals to a here in the substitution, then what will happen? A minus a, which will be 0, means x will be 0, then x is equals to 0. When t is equals to a, then their corresponding value of x is 0. And when t is equals to infinity, if we put this t as a infinity, infinity minus a, that is also infinity. That means when t is equals to infinity, then x is equals to infinity. These two are new limits of integral corresponding to the x. So we can write L of g of t is equals to integral from 0 to infinity e raised to minus p into x plus a f of x dx. Okay, so 1 minute. Now this is again we can write in the way multiply this minus p into bracket minus p into x minus p into a, then we will get here, then we will get 1 minute e raised to minus px into e raised to minus pa f of x dx. समझते का रे स्टूडेंट्स? प्रदीप जमाले. Now this is a purely constant coefficient, so we can take out of integral. That means we will get e raised to minus pa integral from 0 to infinity e raised to minus p into x into f of x dx. Now this is the definition of the Laplace transformation. So we can write this as a f of p, capital F of p. Okay. So Laplace transformation of L of g of t is equals to e raised to minus p a into f of t. This is the second shifting function, you must know. समझला का रे? काय अडचण आहे का? If students सुचिता, प्रदीप, प्रणवती कदम, केंद्रे, समझला ना? If you have any doubt, then you can ask me. Okay. Now next we shall move towards theorem number 4. Change of scale property. Theorem number 4. Change of scale property. Now see here, if L of small f of t is equals to capital F of p, then prove that L of small f of a t we can write 1 upon a into capital F of p minus a. This is the change in scale of scale property. इथं आपण काय रिप्लेस केलं पहा, t च्या ऐवजी जर at घेतला तर लॅपलास ट्रान्सफॉर्मेशन कॅपिटल F of p च्या जागी 1 upon a into capital F of a minus x we can write this. Okay. Now see this by the definition. Now we shall see the proof of this function. What is that proof here? See here, L of f of t is equals to integral from 0 to infinity e raised to minus pt into f of t dt. This is the basic definition of Laplace transformation, but actually we have to calculate the Laplace transformation of f of at. That means we have to change the variable t as a at. So shift the variable, change the variable t as at on both sides, then we will get the Laplace transformation of f of at, which is equals to integral from 0 to infinity e raised to minus pt into f of at dt. Put at is equals to x. Again we have to convert this integral into the standard form of a Laplace transformation. So we have to solve, we have to convert this as a f of t. So shift this variable, we can write at is equals to x. Then differentiating with respect to x, then keep this a is a constant coefficient here. A is a constant coefficient, keep this as it is. Derivative of t is dt, which is equals to derivative of x is dx. Or असं सुद्धा लिहिता येईल पहा. How we can write this? at is equals to x. Now differentiating with respect to x. So a as it is, derivative of t with respect to x, we can write dt by dx, which is equals to derivative of x with respect to x is 1. By variable change property, you can write a into dt, which is equals to dx. Variable separation. So we will get a into dt is equals to dx. You can write any way. There is no problem. Now again, we have to change the limits. because here is t is equals to 0, which is a lower limit. If we put here t is equals to 0, then 0 into a means 0, then value of x goes to 0. When we put the upper limit in this, here a into infinity, t means infinity, a into infinity means again infinity, then the value of x tends to infinity. So these are the two limits. These are the two limits or new limits for our integration. So we will get t is equals to 0, x is equals to 0, t is equals to infinity, x is equals to infinity. Due to this particular substitution, our integration becomes L of f of at is equals to integral from 0 to infinity. These are the new limits, 0 to infinity, e raised to minus p. आता पहा, हा तर काय म्हणते पहा, इफ काय म्हणते प्रण पाटील, इफ देर इज टी इन द फॉर्म ऑफ टू व्हेरिएबल्स, then for standard form we have to take substitution value for given t values. Is it apply for all? No, actually here is a function is in the form of f of t or f of x, whatever may be, but this is a single variable. If this function is a combination of, if this function is a combination of in place of t, a minus t, in this way, then we have to convert this combination into standard form. In such a cases we have to substitute. आपल्याला इथं f of at आहे, पण ऍक्च्युअली f of t असेल तर स्टँडर्ड लॅपलास ट्रान्सफॉर्मेशन वापरता येतं, f of x असेल तर लॅपलास ट्रान्सफॉर्मेशन वापरता येतं. ओके, मग इथं फक्त टी न राहता at आला. अगोदरच्या प्रॉब्लेम मध्ये काय होता, t मायनस a होता, मग त्यांना x किंवा t मध्ये कन्वर्ट करण्यासाठी आपल्याला हे सबस्टिट्यूशन वापरावं लागले. ठीक आहे, हेच विचारत होती का, बघ काय अडचण आली तर परत येऊन कॉलेजमध्ये विचार. ठीक आहे, नोटबुक घेऊन ये, कॉलेजमध्ये विचार, आणखी समजून सांगतो, कारण SMS रायटिंग मध्ये आणखी लक्षात येणार आहे. टी इज द फंक्शन ऑफ द फॉर्म ऑफ टू व्हेरिएबल्स. टी इज द फंक्शन ऑफ द फॉर्म ऑफ वनच व्हेरिएबल. तिथं टी हा फंक्शन म्हणजे टी हा व्हेरिएबलच आहे. टी हा व्हेरिएबल आहे, एकच व्हेरिएबल आहे. टी म्हणजे दोन व्हेरिएबल नसतो, तिथं दोन व्हेरिएबल येऊ शकत नाही. लॅपलास ट्रान्सफॉर्मेशन इज डिपेंड ऑन वन व्हेरिएबल. इन प्लेस ऑफ टी यू कॅन यूज एक्स ऑल्सो. तिथं तुम्ही एक्स वापरू शकता, याला एक्स व्हेरिएबल कुठलाही वापरा. इथं एक्स लिहिला तर इथं एक्स येतो, इथं एक्स येतो, इथं एक्स येतो, इथं एक्स, एक्सच्या फॉर्म मध्ये लॅपलास ट्रान्सफॉर्मेशन होतं, पण दॅट इज अ सिंगल व्हेरिएबल. हो, ठीक आहे. नाउ वी शॅल मूव टुवर्ड्स द नेक्स्ट प्रॉब्लेम. हा, तर इंटिग्रल फ्रॉम 0 to infinity p into, again we have replaced at is equals to x, then the value we can find, right, x by a. So this e raised to minus pt, in place of t we can write x by a. Then in place of x we have write it, इथं t होता ना, in place of t we have written x by a. Again in place of at we have written x, because at we can write as a x, and in place of dt we can write dx upon a. This is the new form of integral. Now see this again. आता पहा, थोडं समजून घ्या, समजून घेतलं तर लक्षात येतं. Now see here, 1 upon a, this is a constant coefficient we can take out of integral. So that may be written as 1 upon a integral from 0 to infinity p upon a into x. P is one constant, a is another constant. This is a combination of constants. This is a combination of constant into x, f of x dx. So if we consider this as a s, p by a, If we keep this 1 upon a as it is, if we consider minus p by a, only p by a as a s, means e raised to minus s into x into f of x dx, then this is the standard Laplace transformation in terms of x. So we can convert this as a f of s. We can write this as a f of s. But s means p by a. So 1 upon a into f into p by a. So the Laplace transformation of f of at, which is equals to 1 upon a capital F of p by a. This is a very important theorem. Change of scale. You have to solve number of problems based on this change of scale property. So you must understand this. L of f of at is equals to 1 upon a into f of p by a. Here in this case variable is variable is t and remaining are constants, or it may be real, complex, whatever may be. आता इथं पहा, यालाच आपण वेगवेगळ्या व्हेरिएबल मध्ये वापरून लिहू शकतो. एल ऑफ एफ ऑफ ए इंटू एक्स इज इक्वल्स टू 1 अपॉन ए इंटू कॅपिटल एफ ऑफ पी बाय ए. म्हणजे व्हेरिएबल कुठलाही वापरा, टीच्या जागी वाय घ्या, एक्स घ्या, पण त्या पद्धतीने स्टँडर्ड फॉर्म असला पाहिजे. आणखी काही शंका आहे का, डाऊट आहे का, विचारा. हे जे 4 थिअरम्स आहेत खूप महत्वाचे आहेत, तुम्हाला हे समजलं पाहिजे. ओके. नाव आता काही ज्या बेसिक डेफिनेशन्स आहेत, या बेसिक डेफिनेशन्स वगैरे ज्या टर्म्स आहेत ते आपण उद्याच्या लेक्चरमध्ये घेऊ. आज फक्त एवढे 4 थिअरमचे प्रूफ तुम्ही व्यवस्थित समजून घ्या, म्हणजे आपल्याला इथं थांबता येईल. उद्या काय आणखी काही डाऊट्स वगैरे आले तर तुम्ही विचारा. कुठलाही डाऊट आला तर थांबून, म्हणजे यू हॅव टू क्लिअरली आस्क एनी डाऊट. ओके. तर आपण इथं थांबू. काही डाऊट आहे का रे स्टुडंटचा? असाइनमेंटची प्रेझेंटी पण घ्या. कोण असाइनमेंट टाकायला लागले, कोण टाकत नाही, याची पण प्रेझेंटी घ्या. ठीक आहे. ओके. नाव पाटील प्रेझेंटी घ्या. ठीक आहे. तर कदम आहे का? कदम नाही वाटतं आज. कदम नाही वाटतं. कदम त्या असाइनमेंटच्या सुद्धा प्रेझेंटी घ्यायच्या. ठीक आहे. तर या ठिकाणी आपण थांबू. उद्याला या ठिकाणी पुढचा पार्ट प्रूव्ह करू. हे 4 थिअरम मात्र व्यवस्थित समजून घ्या.